material. So this is the benefit of this LCA study. Then again, if you see this under one particular boat building material, again difference, like FRP how much it was responsible for this carbon equivalent, then bronze mostly used for in propeller and all that, then what is the copper nail, how much they have contributed towards CO2 emissions. So here also we can know, okay, this FRP is responsible for 41% emission. Bronze is responsible for this one. So where we here we can think, okay, instead of FRP whether we can use some other material, because it's majorly responsible for the emission. So this all way it's going to help. So this is a case study for construction. Similarly for operation also, we have selected some 6 different lengths of boat, where we have analyzed the operational mainly input, that's diesel, fuel, ice, and freshwater lubricating. So this was again this gate to gate approach. Like after one operation, we used to take another one. So in this way, we have seen this diesel. This contributes major 95% of this emission because of diesel. So whether we can check this, so we cannot for the fishing operation, but apart from this, any other substitution we can do. So this way LCA is going to help us. And then after telling all this, I'd like to tell something about energy efficientness. In case of fishing, what all measures we can take to reduce this fuel consumption or increase the efficiency. So one is the steaming speed. Definitely steaming speed, if you reduce the speed, or if you run your engine at the rated RPM, then definitely it is going to burn less fuel. Then propeller, with some more efficient propeller, like on this, there are some propeller having outer guided funnel to pull or push the water in a particular jet manner of the jet. So it's getting more thrust. So in that way, you can reduce your fuel. You can reduce your fuel burning. Then painting of hull, of course, it's going to minimize the drag. So water drag will be less. Then the bulbous bow, the front side of the vessel is having a bow. If it's a bulbous shape, then in that way, we are going to conserve this energy. Then a small and more efficient gear. In this study, you can see this long and this thick vessel is getting speed at a particular RPM, at a particular length of boat, and short and fat vessel at the same length, it's not at this much. So this streamlined body and proper this designing of the vessel is also important for that. Then for finding this fishing ground, selecting the best route with the help of advanced navigational equipments, it's also going to help in the energy conservation. And then use of sail, as much as you can burn the you can use the renewable energy like wind and all in fishing. It's going to help in energy conservation. And of course, in the case of this motorized fishing engines, the turbocharged diesel engine found that it's having more efficiency. And then so many other things in case of gear, there I have listed out how much reduction in total drag. It's there. It's already provided notes. So in conclusion, we can say that LCA is very useful tool for energy optimization, especially in fishing, where different steps are playing a role in the whole process. Then reducing the environmental burdens in terms of so many greenhouse gases, where especially if you'll come to know that, okay, this point is going to contribute more, so you can reduce this, you can slash down this, and in that way it's going to improve your environmental condition. And then it's a way forward towards responsible fishing. I told you about eco-leveling. Then if it's some like eco-leveling, if some way to give a particular fishery about their carbon footprint also. So in near future, you can expect that every product will come as a carbon footprint mark. Okay, this product is having less. So responsibly, we have to adopt this, or we have to use this. Then in long run, this saving of capitals and operational investment is also you can reduce with the help of LCA. Then after analysis, you can improve the design, the product or the process, that is also there. And then of course, last policy and guideline formulation for NGOs and government bodies. It's also one of the output of this LCA. So thank you very much, and I'm extremely sorry for this technical disturbance in between. There was some problem of network, so sorry for that.
Wonderful presentation. I hope all the participants have enjoyed this presentation. Now the topic is open for discussion. You can ask some doubts. I was going through the chat box, but nothing is there. So for us, you can also check in the chat box. No questions. You can ask some.
Okay, thank you, sir. Okay, thank you, sir. Thank you very much, and I wish thanks to all the participants for patient listening. Thank you very much.
Thank you, sir.
Any doubt?
Thank you very much for the presentation.
If no doubt, then I will request the second speaker to talk. Okay, we'll move on to the second talk. Today's second talk is on nanotechnological applications in fishing by Dr. Muhammad Ashraf, Principal Scientist, ICAR-CIFT, Kochi. Dr. Muhammad Ashraf is having more than 28 years of research experience in CIFT in the field of nanotechnology and allied aspects. Dr. Muhammad Ashraf is a well-known scientist not only in India, several parts of the world in the field of nanotechnology and organic chemistry. He has visited several countries to deliver invited talks and paper presentation in nanotechnological application for material protection in the marine environment and related areas. He has got several international publications in the peer-reviewed and reputed journals. And right now, several students are working under him for PG programs as well as PhD.
Hello, good evening, good morning, good afternoon to all. Can I hear?
Good morning.
Yeah.
Good morning from
Good
Zambia.
morning, sir.
Yeah.
Good morning.
The topic I am presenting here, the nanotechnology and its application in fisheries. And,
Good morning.
Yeah. And this topic, it is as a new, comparatively new area of research in the fisheries sector. And my talk always will be comprised of I will talk initially regarding the history and what is nanoparticles, nanomaterials, and its classification, what are the important applications in fisheries, and then apart from that, what are the work we are going to do here in CIFT, and then finally conclusion. The industrial revolutions were seen in steam engine, textile, and then finally 1950s we were entering the semiconductor, computer, chemicals, and synthesis and all. And in 1980s, 1980s it is the term nanotechnology, molecular manufacturing, etc. has been dominated in this world. The term nanotechnology means nanotechnology was introduced by Taniguchi in 1974 during a conference in Japan. And then later, 2007, the term nanotechnology means a domain of scientific activity oriented on synthesis, investigation, application of devices, or development of materials and technical systems. And generally the nanomaterials will be considered, the material considered as nanomaterial, it is 1 to 100 nanometers. And then during 1959, the Professor R. Feynman, an American physicist and Nobel laureate, has predicted that there is a plenty of room at the bottom. So, and then he pointed out that if you can control a material in size and shape in size and molecular orientation, we can make wonders. That is what he pointed out. That we can see in the right side, it is the particle, the right side, the blue color. If it is a particle it is a gold nanoparticle, and its size was very small. The color was red, and then if size goes on aggregating the gold nanoparticle, it becomes blue. So you can imagine that what is the size of the nanoparticle is. It is 10 raised to minus 9 meter of a 10 raised to minus 9 particle meter, 9th particle of a square meter. So that is called nanoparticle. So that is on billionth of a meter. That is, and in principle, nanotechnology means you have to make a bigger particle, and if you make it smaller and smaller and all, the properties are same, but the function, the activity will be more. That is a major function at the nano sizes. In short, nanotechnology refers to the process of fabricating a particle of materials having 1 to 100 nanometer in size. And this is the general representation of nanomaterial. You can see different tennis ball, and then even a point in our writing. It is 10 raised to 6 nanometers, but we are considering only 1 to 100 nanometers. It comes liposomes, dendrimers, gold nanoparticles, etc. And then in short, what you can say, if you are having a 1 square meter cube of sugar or any particle, you divide. It is you can see the area is 6 centimeter when it was in cube. If you divide into 2 particles, it becomes 8 centimeters. The total area becomes 8 square centimeters. That is a 33% increase in the surface area exposed to the environment. Similarly, if you are cutting into 4 sizes, what will happen? The total area comes into 10 square centimeters. That means the 66% of the initial particle. Similarly, if you take a hammer and crush the sugar cube, you will get hundreds of particles. Then we will get an enormous surface area available for reaction. Just like our sugar, if you are taking a sugar particle, put it on